Okay, in this video, we're going to be using expected value with probabilities, binomials, and areas. So what is expected value? So really what this is let's say you go to a casino and you gamble some money. How much should you expect to leave with? That's the basic idea of expected value, some formalization of that idea. Okay, so to do that, we're going to multiply each probability by its earnings and sum up. So let's take this example. If you have a game where heads leads to earning $5 and the tails makes you lose $10, this is how you do expected value. Okay. So since the earning $5 has a 1/2 chance, so probability by earnings 1/2 times 5. But here we add the -10 times 1/2. Okay. And in total, we lose negative 2.50 usually. Okay. So we can just tell right off the bat, this game is an unfair game. We're going to be expecting to lose money. Okay. Let's go on to the lottery. So we can calculate the expected value in the Florida lottery to see if we can call this a fair thing. Okay, so let's go to decimals real quick. Okay, I put these into a table. And what we're going to be doing is multiply this by this, this by this, this by this, which we can do really nicely on decimals. So really what we're asking for is E times P. This E times this P, this E times this P, and we want to add them up, so we do total. Okay, so we get that the expected value is 0.66, which sounds good, right? We're earning money, but remember that you wasted this on a $2 ticket. So let's subtract that $2 expense, and we're losing money. Once we factor in that we paid $2 for it, it doesn't look like such a good deal anymore. We're going to be losing $1.33 usually. Let's go back. Okay, expected value negative $1.33. And I guess a lot of people don't do gambling. Even if you do win the jackpot somehow with this 1 in 300 million chance, it's not going to make up for it. You're probably still going to lose money. Okay, let's learn some more techniques other than just multiplying out. Okay, word and name arrangements real quickly. That's when we had, let's say, 3. This would just be 4 factorial, right? Because each letter is distinct and we have no issue. So first place, there's 4 options, 3 options, 2 options, and then 1 option. So we have 24 ways to rearrange this. But if we have repeats, like let's do this, A, D, R, I, A, N, it's not just going to be 6 factorial here. This would be the beginner mistake. You have to account for the fact that these A's repeat. You can't tell them apart. So we had AA, D, R, I, A, N. You actually can't tell which one is which. So you have to divide by the number of ways there are to rearrange these A's. So divide by 2 factorial. And some 6 factorial is going to be 720. 720 divided by 2 is 360 ways. And if we have more repeats, like let's say we have ska, I don't know what that means. Just a pretty sounding thing. So ska, 6 factorial divided by, there's 2 s's that repeat, so 2 factorial. 2 k's that repeat, so 2 factorial. And 2 a's. Okay, so this is 6 factorial divided by 6, which is 5 factorial, so that's 120. 120 ways to spell ska, if you're ever asked that. Okay. So let's see how we can use this to find some probabilities. Adrian is taking his 10-question chemistry final, which is true or false formatted. What is the probability that he passes with exactly a 70%? Assume Adrian has never done chemistry in his life. So in other words, this is random. Okay, so we can model my test with some letters. Because if it was 3 questions, and I got a 66%, that would mean I would have to got 2 right and 1 wrong. I also could have gotten the first question wrong, and then 2 rights. Right, wrong, right. It's going to be the same idea for this problem. So since probability is number of successes divided by number of possibilities, let's find how many successes or things like this we can get. Because this would be what I want. I have 7 right answers and 3 wrong answers. Let's see how many variations of this there are. Okay, so since there's 10 total letters, we do 10 factorial divided by 7 factorial, since 7 R's repeat, times 3 factorial. Let's evaluate this real quick. Let's go back to this one. And factorial divided by 7 factorial times 3 factorial, we get 120. Okay. So there's 120 ways to get a success. And now let's count how many possible tests there were. See how lucky this is. Okay, so say there's just 10 slots. So there's 10 there. For the first question, there's 2 possibilities. So 2 is true or false. Next one is also true or false. So times 2, 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 and so on. So the number of possible tests is going to be 2 to the power of 10, which is 32 times 32, which is 1024. Okay, let's evaluate what this is. 20 divided by 1024. Let's divide by 100. I get 11.7%. Doesn't sound too good, but pretty good considering he's never done chemistry in his life. Odds aren't too bad. Okay, let's go on to area probability. So this is with geometry, but instead of counting, we're going to be finding areas and dividing success of area by total area. Okay, so let's do this one. Adrian is very bad at sports and is tasked with shooting a hoop in basketball. Find the probability he makes the shot given his shot is random in this area, and the hoop is a circle with radius 3, while the entire board region is a square with side length 10. Okay, so I realize this is not a square. Let me fix that. There we go. So let's find the area of the circle, which is our success region. If it has radius 3, we're going to use pi r squared. Plug in r equals 3, you get 9 pi for the success region. And then we divide by total area. So if it's side length 10, it's going to be 100 for the total area here. Okay, let's evaluate that real quick. 9 pi of 100 is 28%. Okay, 28% probability. But preferably, you would leave it in this format. Exact answer. Okay, that's how you do an example problem for that. Now let's go on to some bets. See if you should do these or not. Okay, next here. So we have bet 1, shooting a target. You must pay $10,000 to participate in this bet. Okay, let's see it. Imagine a 25 by 30 paper with a 2 by 3 rectangle drawn inside of it. Connect the midpoints of the sides of the rectangle to form a diamond. Split the diamond into 4 equal parts in shape 2. The target will be shot randomly, ensuring it at least lands in the total region. Okay. If you hit the shaded region, you earn $1 million. If not, nothing. Should you take this bet? Okay, instead of getting blinded by this $1 million, let's draw out what this might look like. Okay, so 2 by 3 centimeters. So that'd be like 1/10 of this. Maybe like that. I'm gonna remove the fill here. Okay. And it says connect the midpoints of the sides to form a diamond. Let's come here, make a diamond. Okay, let's draw 4 equal parts. And it must land Decide here or here. Okay, so it must land on that black stuff or else you're not getting the $1 million. Let's do the math now. So first let's find the area of these black regions. Okay, so this thing is 2 by 3. Let's label it such, so 2 times 3. And what's going on here is when you're dealing with midpoints, you can usually generate a bunch of congruent triangles. Since this one are the same, this one's the same, this one's the same, this one's the same. You actually have 8 equal triangles here, and 2 of them are shaded. So that means 1/4 of the area here is shaded. So that's 1/4 times the total area, which is just 6. Okay, so the area of these two little triangles, or the success region, is going to be 1.5. And the area of the total region is, again, 25 by 30. Let's put that in real quick. Calculator. 1.5 divided by 25 times 30. And then we put in the 1 million cash reward here. That's 10 to the 6. Okay. And now we subtract the cost of playing, which is 10,000, and negative 8,000. So since that's negative, we're going to be losing the money from this game. Because this area is just so incredibly difficult to get, this game is not worth playing. Okay, so the answer is no, don't take the bet. Okay, bet 2, deck of cards. You must pay $10,000 again to participate in this bet. Here's an offer. Draw a card. If it is a face card or an ace, you win $35,000. If it is not, then you earn nothing and I keep your money. Okay, and for those of you not familiar with the standard card deck, there are 52 cards with 3 face cards for each of the 4 suits. Furthermore, there is an ace for each of the 4 suits. Okay, so let's find the probability of getting one of those good cards. Okay, we want a face card, and there's 3 for each of the 4. So far we have 12 good cards. And for the suits, an ace for each of the 4 suits. So we add 4, 1 more good cards, and we divide by 52. This would be the probability of getting a good card, and we multiply it by its earnings. So times 35,000. And then at the end, we're going to subtract our playing cost to see if this is fair game. Okay, so let's put that in, and then we subtract 10,000. Okay, and this bet is also negative, so that means this is not a fair one either. Okay, so nope, you should not take this one either. And next one, Scrabble Letters. Okay, you must pay $10,000 to participate in this bet. However, you may lose more than 10,000. Okay, so we can pay them $10,000, but really lose 80,000 in the end if we had to. Okay, draw 3 Scrabble tiles from a bag of 60. There are 18 total vowels, and the vowels replaced after each draw. Okay, and then let's mention real quick here that we're playing with a modified deck. It's just the vowels and consonants. There's no spaces or anything. Okay, here are the rules. If you get 0 vowels from those 3 draws, you get nothing. I keep your money. If you only get 1 vowel, then you earn 20,000. If you get 2 vowels, then you earn 20,000 as well. But if you get 3 vowels, then you lose 90,000. On top of this 10. So should you take this bet? Okay. And this is binomial probability again, the word arrangements I showed y'all. So let's try the first case. So 0 vowels. So in other words, let's call that consonant, consonant, consonant. And we're going to find the probability of getting each consonant. Okay, so the probability of getting a vowel is 18 over 60. That implies the consonant would be 42 over 60. It's more common. Okay, and we get 3 of these in a row. They're independent events. So this is going to be 42 over 60 times 42 over 60 times 42 over 60. Okay, and we multiply the probability by the earning. And even regardless, this would earn nothing. So times 0. Okay, now for one vowel, we could get 20,000. Okay, so that would be consonant, consonant, vowel. And keep in mind here that this would be the same as CVC or VCC. So if you find a number of arrangements of CCV, for the harder ones, so there's 3 ways to do it. 3 times, and we'll do the probability again. So the consonant is 42 over 60. Another consonant is 42 over 60 times the probability of a vowel, which is 18 over 60. Okay, and if you ask what the 3 here is for, it's because there's multiple ways to get this. So we want to triple the probability of just one. Because here, since there's only one way to get CCC, we can just leave it here as 1 times this. Okay. Okay, we multiply this by the earnings, so times 20,000. 20,000. Now let's do it for 2 vowels. So C, C, V, V. Again, there would be 3 arrangements of this thing. It's going to be 3 times the probability of consonant. So 42 over 60 times 18 over 60 times 18 over 60. And again, the vowel is replaced after each draw, so the probability of getting a vowel is always the same. Okay, and we multiply by the earnings, which is going to be 20,000 as well. Okay, now for the last case. If we get 3 straight vowels, we actually get punished. But there's only one way to do it, so it's 1 times. Let's do this. 18 divided by 60 times 18 divided by 60 times the final probability, which is getting the third one, 18 divided by 60. Okay. And earnings would be lose 90,000. So let's put that in. 90,000 graphic calculator. Okay, so here I use the formula to speed it up. This is the binomial probability formula. You can find it online, but I prefer doing that other method if you don't have this written down or memorized. Okay, and we find that after adding all these up and subtracting the $10,000 fee, we actually gain money. We expect to earn around $170. So this is a good deal. I would take this bet. Okay, I hope you enjoyed this video.